talking about the silicon and software solutions that AMD has for HPC. So I'm the segment manager for HPC for AMD. So think about anything having to do with HPC within the company, whether that is working with our performance labs or organizing events like this. That's kind of my role within the company. So like I said, my contact info is up there. Go ahead and please reach out to me for any inquiries about AMD's HPC solutions. Yesterday we talked about kind of the technologies that AMD Research is working on, the things that we're doing from a long-term standpoint. Today I wanted to focus on the products that are in market today or are going to be coming to market later this year. So that's why we got the cautionary statement, because we're going to talk about some products that aren't in market yet. But like I said, that's going to be the focus, is the products that are either in market today or will be coming into market this year. And while our brands are new, so the AMD EPYC brand was introduced a couple of years ago. Our brand for our GPUs, we call it RADEON Instinct. That brand is new. The technology has been around for almost 20 years. So AMD has been an innovator in both server CPUs and server GPUs for almost 20 years. So we introduced AMD 64, direct connect architecture. We were the first GPU with double precision floating point. And then more recently, we've got the first GPU with PCI Express Gen 4. And built-in 7nm technology, and our upcoming product from a CPU standpoint that we talk about, it's going to be the first x86 processor with PCI Express Gen 4, also built in 7nm. So using leading-edge manufacturing technologies and bringing leading-edge I/O connectivity to the market. From a kind of roadmap standpoint, where we're at now, we're kind of in the middle of this journey that's up there. So the EPYC 7001 is our product that's in market now. The product that is going to be coming to market later this year, we call it Rome. That's the code name for it. And then we're continuing to develop our next generation product, Milan, which is scheduled to come into production next year. From the RADEON Instinct side of the house, the MI25 is a pretty mature product that we've had in market for a while. Last year, we introduced a product we call the MI60, which was the first GPU that uses 7nm manufacturing technology, and that uses PCI Express Gen 4. And we're continuing to develop that roadmap as well. We code the next product on that roadmap, we codename MI Next. But like I said, continue to innovate on both the CPU and the GPU sides of the house. Our current generation EPYC processor, it's the 7001 generation. We believe that this is the right product to power, optimize, and secure your workloads. So it provides up to 44% higher performance than competing solutions for weather modeling. Also has a significant performance advantage for computational fluid dynamics simulation. So any kind of workload that is heavily memory bound, we believe we're going to have a great solution with the EPYC 7001. Also, we've got a consistent feature set across the full stack. So like I said, that allows you to pick the right balance of overall performance versus per core performance. If you need to have a better balance of memory bandwidth to core versus the best overall performance, you're going to get a consistent feature set within the full EPYC lineup there. We also have unique security features, which we believe, I talked a little bit about it yesterday, but those security features we believe are really unique and essential for protecting the data that all of you are creating in your research. Also, we support those with a robust ecosystem of compilers and libraries, and have strong ISV relationships with the major ISVs. So ANSYS, Altair, MSC, et cetera, all the major ISVs within the HPC community we have strong relationships with, as well as the open source communities. So looking at the EPYC 7001 product in more detail, like I said, this is a product that's offered in 8 to 32 cores. One of the big differences with this product versus other products that are out there is 128 PCI Express lanes. So any workload that you're doing that's storage heavy, I/O heavy, or accelerator heavy, I believe this is going to be the best product for this. You can connect 24 NVMe drives directly to this processor, so you don't need to have any type of PCI Express expanders. You don't need to worry about oversubscription of your storage subsystem. I was at a conference last week where Ulrich from CERN was there talking about their data collection needs, and they use 300 gigabit Ethernet NICs that they overclock to 110. So 330 gigabit per second of data ingest into their servers for that solution. This type of a solution is ideal for anything that's high I/O like that. Or, like I said, the third scenario is if you have a lot of FPGAs, a lot of GPUs, whether those are from AMD or from other providers, we've got a great scale-out solution for heavy accelerator workloads. Like I said, we talked a little bit at a high level about those security features yesterday, but going into a little bit more detail, we have a technology called Secure Root of Trust. So this will allow the firmware to be booted in a secure way, as well as a technology we call SME, or Secure Memory Encryption. And this allows you to encrypt all reads and writes to the memory subsystem. Again, we believe this provides superior security to any other solution that's available today. And from a software standpoint, we develop our own libraries, compilers, and tools. So AOCC is the compiler that we use, the AMD optimizing C and C++ compiler. We also provide a large array of libraries, BLAS libraries, FFTs, random number generators, as well as profiling tools. So, for looking for hotspots in your code, areas where you may want to vectorize the code, areas where you may want to do loop unrolling, we have all of those tools available from AMD. We also work closely with the LLVM community as well as the GCC community. So, like I say, we're strong relationships with the open source communities as well as the AMD developed software tools. And from a CPU and library standpoint, like I said, the products that we have in market right now, we call them the version 1.3. Later this quarter, we'll be coming out with the version 2.0, which has enhancements for the Zen 2 core. The Zen 2 core is the core that is in our next generation server processor. We call that processor Rome. I'll talk about it in a few slides. And then we're continuing to innovate on the CPU and library, or like they said, the compiler and library standpoint. And in the second half of this year, the compilers and libraries will have the Zen 3 enhancements for our future generation product that's going to be coming out in 2020. So talk some about the CPU silicon and CPU software. Next, wanted to just spend a couple minutes talking about our GPUs and our most recent product. We call the RADEON Instinct MI60. This was a product that was introduced in November of last year. I talked about it a couple different times. It's the first 7-nanometer GPU with 32 gigabyte of HBM2. It's got a terabyte per second of memory bandwidth, and it's got ECC on the memory. So, like I say, advanced security and reliability features in the GPUs, complementing those features in the CPUs. This product has got leading SGEM and DGEM performance. Also, we've got scalability for half rate precision and T8. Like I said, so the flops or the integer ops, as you use machine learning types of data sets, scales well for those types of data sets as well. One of the really unique things about the MI60 is the Infinity fabrics that we have connecting the GPU to GPU. So what you see here in the bottom half, you're able to connect up to 4 GPUs with a coherent interconnect that we call Infinity fabric. That's 100 gigabyte per second link, so that up to 4 GPUs can have a coherent memory space. Then they connect to the host processor over PCI Express Gen 4. So like I said, enable you to have coherency CPU to CPU, as well as coherency GPU to GPU, and then the PCI Express link connecting the CPUs to the GPUs. From a software standpoint and the GPU standpoint, we have a open source set of libraries and tools that we call ROCm. And so whether you're developing new software in OpenMP or OpenCL or Python, we support all of those through ROCm, as well as a tool that we call HIP. So if you've developed or used source from NVIDIA, let's say with their software stack, HIP will take that software, translate it to C, and then once you've got a native C code, you can compile that to either an AMD target device, an NVIDIA target device, an FPGA, whatever kind of device you want to target it to. So like I say, we've got HIP to take CUDA code and run that on AMD products or products from other folks, as well as support for OpenMP, OpenCL, and Python. So a really broad spectrum of software support for the GPU ecosystem. So the last couple slides, I wanted to talk about our upcoming product. So this is a product that's codenamed Rome. I talked about it a little bit yesterday from a technology standpoint. The chiplet architecture that we've used to develop this product, I believe that 5 to 10 years from now, this is how all server CPU processors are going to be built. in 2019, Rome will be the only server processor that's available using this technology. And so we talked about it at a little bit of a block diagram level yesterday, but this center die, this is the I/O die. So that's where your PCI Express connectivity, your memory channels, your Infinity Fabric connectivity to the other processors in the system are all on that central die. These 8 smaller die, each of these is where the cores and cache are. And those are the parts of the product that are optimized for that 7 nanometer manufacturing technology. And so with the performance per watt we're able to get from this architecture, as well as the leading manufacturing technology, we're able to get up to 64 cores. Again, these are all based on our new Zen 2 architecture, which doubles the floating point throughput per core. So you got double the floating point throughput per core and double the cores per processor. Again, that EPYC 7001 that's in market now, that's a 32-core processor. With the enhancements of the Zen 2 core, we have higher IPC than we've got with our product that's in market now. And with the I/O capabilities and the memory bandwidth capabilities, again, we believe this is going to be an excellent, very balanced solution for your HPC workloads. Like I say, by routing all of the I/O through this central die, you'd have very consistent latencies, very consistent bandwidth across all of those CPU cores. And again, just to complement the PCI Express Gen 4 GPUs that we have in market, this will be the first x86 server processor with PCI Express Gen 4. So, capabilities for our accelerators, capabilities for next generation SSDs that are going to use PCI Express Gen 4 for next generation FPGAs, as well as for connectivity. So if you're using Ethernet connectivity, you can get up to 200 gigabit per second Ethernet with this solution. If you're using InfiniBand, you can get up to HDR InfiniBand speeds with this solution. And so how that all kind of translates, all those sets of features and innovations translate to performance. This is going to be up to double the performance per processor of that current generation AMD EPYC 7001. From a floating point standpoint, again, we double the floating point resources per core, and then we double the core count per processor, so up to 4x the floating point resources per core. So really significantly beefing up those floating point resources to go along with that great memory bandwidth performance that we've got today. Finally, I wanted to just talk about some of the customers that have made the choice to use AMD EPYC processors. So HLRS is going to be deploying a system later this year that's going to use 10,000 Rome processors. That's going to be a 24 petaflop system. NERSC announced last year that they're going to be using a future generation AMD processor for their NERSC 9 system, which will be deployed in 2020. NICAF they work in collaboration with CERN. They're using our current generation AMD EPYC 7001 in their solution, as well as a series of solutions, whether folks are experimenting with HPC in the cloud. You can get HPC in the cloud solutions from Microsoft Azure as well as Oracle. And then we've got universities across the US and Europe that are using our solutions. In addition to these customers that have kind of given us the rights to use their logos, we've got other customers that have made public statements of support for AMD. So Procter & Gamble is going to use the Rome processors and their technology. Lawrence Livermore Labs is already using, they deployed in December of last year, the current generation AMD EPYC and the current generation MI25 GPUs, as well as CSC in Finland is going to be using a solution based on AMD Rome processors for their solution. So momentum is building within the ecosystem for people that are adopting AMD-based solutions, like I say, from a number of our OEM partners. And so we really believe that this is the start of the next wave of innovation from AMD, and we're excited to work with all of you on that. Thank you so much.